And you are of course most welcome. This is Project Euler, problem number 15, lattice paths. Starting in the top left corner of a 2x2 grid and only being able to move to the right and down, there are exactly 6 routes to the bottom right corner. How many such routes are there through a 20x20 grid? Okay, now as far as I'm aware, there is only one solution to this, and it's so simple that I'm not even going to program it. It is literally something you can do in a calculator. So let's go to the board, and I'm going to take this 2x2 grid and turn it into a diamond. So something a bit like this. So here's our diamond. Let's make it a lattice. So we'll do this and this. There we go. Right. Let's mark all the points as well. Why don't we do that? There we go. So there's our lattice. Now let's figure out all the paths through this lattice. So from this point to this point, obviously there's only one way. What about from this point down to this point? One way. This point to this point, one way. This point down to this point, one way. And this point down to this point, one way. What about this point in the middle? You can go two ways. There's one way here and another way here. So that's two ways. And the mathematicians watching this will already be screaming Pascal's triangle at the screen, and they are absolutely correct to do so. What about this one down here? How many paths are there? It's getting a bit scruffy now, but I think we're okay. So there's a path this way, there's a path this way, and there's a third path going this way. That's three paths this way. And similarly with this one, there are 3 paths. 1, 2, and 3. 3 paths. This is indeed Pascal's triangle. So if we do the next row, 1. Now the next row is formed by adding the 2 numbers either side. So this number here would be 1 plus 3, that's 4. 4 goes there. This number in here would be 6. This number in here is 4, and then a 1 on the end. And we can do the next row as well. 1, 5, 10, 10, 5, 1. And we just keep on going. So this is the 0th row, because you can't go anywhere on that row. You're just stuck at that point. This is the first row. This is the second row. This is the third row, and this is the fourth row. So despite it being a 2x2 grid, the answer is actually found on the fourth row. So in a 20x20 grid, the answer would be found on the 40th row. So n equals 40. And it would be in the middle of the 40th row. So I'm going to say r equals 20. Now there is a formula for finding a specific number in Pascal's triangle. I'm going to show it to you right now. So it's n factorial divided by r factorial times n minus r factorial. So let's try and find this 6. We know that this is the fourth row, and it's the 0, 1, 2 second values, all 0 indexed. So it's the fourth row second value. So 4 factorial divided by 2 factorial times 4 minus 2 factorial. That simplifies to 4 factorial divided by 2 factorial squared. Okay, which is 4 factorial is 24. 2 factorial is 4, and that's 6. Thank goodness. So the solution to this problem is 40 factorial divided by 20 factorial times 40 minus 20 factorial, which on your calculators is simply 40C20. Don't do it on your handheld calculators though, because the number is way too big. Do it on an internet calculator, or do it in Python. You can do it that way. So that's it. That's it for problem 15, and I'll see you next time for problem number 16.